Before we move on, let's pause to consider an analogy that will help us to understand the multiple access technologies we've been discussing. Suppose you're going to a cocktail party, and there's a host inside, and the host wants to make sure that every two pairs of people that arrives can have their conversation. So we just assume that you're going to the party with someone else, and that you want to just be talking to that person at the party. So one way that the host could accomplish this is by putting everybody in a separate room that's socially introverted, but you could have everyone in a separate room and then nobody would be able to hear anyone else's conversations. So clearly this wouldn't actually happen at a cocktail party, but just bear with me for a minute. So you could put this group in this one room, you put the next group that arrives in the second room, and so on. So what each of these rooms is representing is a different frequency. So we have one pair or one link on one frequency, one pair, another link on another frequency, and so on, which is synonymous with an FDMA system. So again, each room was a different frequency channel. And we continue as every future pair arrives to put them in a separate room. But now, what happens when another pair arrives right now, or a few different pairs arrive? Well, we don't have any more rooms in the house to fit anybody else. So we need to figure out a way to have multiple people be able to stay in the same room and still communicate. So on top of this FDMA, we can put multiple people in the same room if we allow some other sort of scheduling or some other way of sharing. So now even that resource, this frequency resource that originally every link had one of, now we have to even divide that resource up. And one way we could do that, as we have a lot of people arrive, is through TDMA, where we basically within every room we have a scheduling happen and everyone takes turns. So in this room up here, for instance, one group could go first, then the next group, and the next group. And then it would repeat. So this group, then this group, and this group goes. And so then nobody in one room is speaking at the same time. So clearly this is very unlikely to happen at any party that you would ever go to. But this is an example of TDMA now over the top of FDMA, or sometimes it's abbreviated as F/TDMA. Where now within each room we have a time scheduler and people are taking turns within that time. But the main idea is again that at any given time, in any given room, only one link is speaking. So now, with CDMA, we would break down these walls. And we would allow everyone to speak, but say in a different language. So again, for CDMA we need different codes, but so suppose then everybody at this party was speaking in a different language, and we had every group of individuals speaking in a different language to one another. Now, if these languages would not interfere with each other at all, if there were two completely orthogonal languages, which that doesn't necessarily even make any sense, but if you could design two languages that would not interfere with one another, or you could design a set of however many people we have here, however many links, that many languages that would not interfere with each other, then that would work really well. And everybody could speak at the same time, just in different languages. But clearly, human vocal cords were not designed to be perfect transmitters in different languages. So the problem is that even if I'm speaking in English and you're speaking in Spanish, even if you can't understand what it is that I'm saying, I'm still going to interfere with you because you can still hear my noise. It would really be noise to you, my conversation. So if I'm speaking one language and you're speaking another language, you can still hear me even if what you're hearing doesn't make any sense. So we need a way to control the volume of our voices, say some courtesy procedure, so that each of us can say how loud we are going to be talking. So we come up with some consensus that will work for every group of people in this room so that we can all have our conversations without causing too much interference to one another. And that idea will be recurring throughout the rest of this lecture.